Hello learners, welcome to this course on preparation of research proposal in social sciences. I am Dr. Pratik Chaurasia, Assistant Professor, Faculty of Education, Banaras Hindu University. Today we are going to discuss our module 8, which is based on data analysis, delimitation, referencing and budgeting. And within this module 8, we will discuss our lecture number 36, which is based on quantitative data analysis. Key learning themes for today's lecture. What is quantitative data analysis? Levels of measurement, steps in quantitative data analysis, descriptive and inferential statistics, other aspects of quantitative data analysis, limitations of quantitative analysis. So, let us discuss all these themes one by one. First is, what is quantitative data analysis? Very important. We have discussed what is quantitative data, what is qualitative data, but today we will discuss how to analyze quantitative data, because whenever you are going to prepare your research proposal, there will be a section that will come that how you will analyze the data, you have to write it. So, let us discuss this. Quantitative data analysis involves systematic techniques to examine numerical data. Very important thing. It aims to test hypotheses, determine relationship and make predictions. Often follows a positive research paradigm commonly used in experimental, survey and correlational studies. Now here one thing is very interesting and very useful for making a research proposal and defining your data analysis section under research proposal, that when you are making a research proposal, you are having tentative ideas about what will happen to you when you will go for data collection, because you are defining that I will do like this. You are trying to persuade that these things I am going to do and these are very effective. But there will be many kind of a practical constraint that will come in front of you when you will go to collect your data and when you will have your data, and most challenging thing when you are going to analyze your data. So, as a researcher, as a proposal maker, be very cautious regarding not to write too much towards data analysis section. This is important because you are actually not knowing what kind of data you will have. Let us take example of quantitative research. For example, when you want to collect a data, and data, nature of the data, you are pertaining that it will be quantitative, but after the data collection, when you are going for analysis and you are looking into the nature of the data obtained, may be the case that the data you obtain may be not normal in nature. It does not meet the assumptions of normality. Then you have to use test according to the nature of your data. This is very important. Generally in a research proposal, a proposal maker used to write that I will use this and this test for analysis. It may be right. It may be right when you are claiming that you will use some certain kind of a statistical test for analysis, but it may be case that what you claim may not come true after data collection. And this is the honesty and ethical aspect of a researcher, to be very honest towards this aspect also. Do not try to be over predictive towards your statistical test or other kind of a data handling aspect, because real analysis comes into the play when you are having data with you. It's a very research sensibility, I would say, that show the research sensibility, that write less because you don't know actually that what will be the nature of the data. You have a tentative idea that I am going to have a quantitative data and I will use t-test or ANOVA, but the moment you collect data and when you check it for further analysis and you found that data is non-normal in nature, then there is no scope for using parametric test, because it does not meet the assumption of parametric test, even though you claim in your research proposal. So it is better you claim it in a little softly manner, where you are not strongly saying anything, you are writing in a tentative manner that this is my design, this kind of design yields this kind of a data, and this is my sample. So I will move accordingly. So let us see here that whenever you are doing quantitative data analysis, it is basically a systematic technique to examine numerical data. And this kind of data are commonly emerging from experimental kind of research design, survey type research design, and correlational studies. Now, levels of measurement. It is very important to understand what is levels of measurement. There are basically 4 levels of measurement. First is nominal, then ordinal, then interval, and then ratio. So let us discuss all this one by one, because whenever you are going into the data analysis phase, you have to be very clear about levels of measurement, that your data belongs to which levels of measurement, whether your data is of nominal level, whether your data is of ordinal level, whether your data is of interval level, or your data belongs to ratio level of measurement. So first of all, let us discuss categories without order. Example, gender, school type. Very important. The data which is of categorical nature are generally coming under the category of nominal level of measurement. Second, ordered categories. Example, Likert scale and grades. Whatever data you are getting in a ordinal categories, they come under the ordinal level of measurement. Numeric scales with equal intervals but no true zero. Example, temperature in Celsius. It's a kind of a interval level of data. Last is numeric scales with a true zero. Example, test score or attendance. Very important that whenever you are collecting your data, you have to be very cautious about understanding the nature as well as levels of measurement, that in which level of measurements your data belongs. Because if you are making a mistake into understanding this thing, then definitely you are going to do mistake in selecting some certain kind of a statistical test, because there are assumptions. Every statistical test has some certain assumptions, and if that assumptions is not met or you are violating that assumptions, ultimately data analysis is not going to be genuine. I am repeating it again, that whatever you are doing with the help of SPSS or Excel or any other kind of a statistical softwares, definitely they will give you some result, but that result is not appropriate if the assumptions are not met. So whenever you do your data analysis, look into this aspect, and when you are designing your research proposal also, be very specific in terms of guessing level of measurement, that what kind of a level of measurement your tool, your design will yield, and write analysis accordingly. Steps in quantitative data analysis. How to do? Let us see it step by step. First is data preparation. How you will start, how you will begin? You have to prepare the data, that is data cleaning and coding, because whenever you are collecting data, you have a huge amount of data in a raw structure which does not follows any kind of a system order or any kind of a systematic arrangement. So as a researcher, it is your prime responsibility that whenever you are starting data analysis, especially in quantitative data, while handling quantitative data, use data preparation, cleaning and coding. Second is descriptive statistics, summarizing data. You have to understand that how to summarize data. For example, you have a large amount of data. So let us see first of all what is the variance of the data. Let us see how mean deviates from the normal. We have to see this thing, because it is not like that you directly rush for any kind of a statistical test, that you have a raw data, you have coded it. Even though you have coded it properly, you are not directly jumping to use any kind of a statistical test, because there are several kinds of assumptions and parameters. Without satisfying them, you cannot move forward for utilizing some certain kind of a test. So if assumptions are met, you have to move forward, and for looking into the nature of data, that how data has deviated from normal, what is the variation of data, how much data has a standard deviation. All these things you have to look with the help of descriptive statistics. In a nutshell, you can understand it that whenever you want to summarize your data, understand your data, initially go for descriptive statistics by using mean, median, mode and other descriptive statistics. After that, you will have a clear cut idea about nature of your data. Clear cut idea you will have that now this is my data, whether it is suiting toward the normality of the data, whether it is suiting towards the variability, whatever condition you want to see as a researcher, you can see it, and accordingly you can move forward. Move forward means if the assumptions are met, if the normality is satisfied or other assumptions are satisfied, data level, categorical level, nominal level, ratio level, what is required, you have to move forward for inferential statistics. And here one more thing I will add, that whenever you are using correlation also, you have to see that you are not rushing for any specific kind of a correlation. You have to see the requirement of correlation. For example, some correlations required to see dichotomy of the data. If the two variables are there, are they dichotomous in nature? It is being required. Are they continuous? Are they discrete? So all these things you have to see with the help of initial data observation, and if it satisfied the need and assumptions, move forward for using any kind of a best inferential statistics in the form of parametric or non-parametric test. Final is interpretation of result. How to interpret it? Whenever you collect data, you analyze your data. On the basis of that, you have to make meaningful inferences, and for that you can consult standard books, review of literature, or if you have supervisor with you or any other senior colleague with you. So because interpretation is very important. For example, if you are using some statistical test, and let the test says that the f value is 3.79, f value is 3.79, then what does this 3.79 signifies? It's a numerical value for a layman person, but for a researcher who is eyeing towards the objective of the study, who is eyeing towards the hypothesis what has been already defined, they know that what this f value signifies. Therefore, whenever you interpret your result, look into this basic statistical aspect to make meaningful and appropriate inferences. Descriptive versus inferential statistics. Now, this is important. When you are going for a quantitative research data analysis, you have to be understood these things, that what is the basic difference between descriptive and inferential statistics. First of all, let us discuss what is descriptive statistics. Used to summarize and organize data. Used to summarize and organize data. Includes measure of central tendency like mean, median and mode. Measures of variability, range, variance, standard deviation. Graphical representation, bar graph, histogram, other things. Let us take one example. Average math score of a student from rural and urban schools. The moment you are looking toward the average scores of rural and urban schools, you are using descriptive statistics. I will repeat it here again. With the help of descriptive statistics, you seize the tendency of the data. What is the tendency of data? Is it more normal? Is the mean deviated from the normal? What kind of a standard deviation is there? What kind of range is there? What kind of variance is there? This all thing tells you about the data, that how data behaves. And as a researcher, it is very important that you have to understand your nature of data, whether it is quantitative or qualitative. Without understanding the nature of data, this is a phase where researcher can commit serious mistake while designing research proposal or whenever you are executing your research. So it is very important to look into these things. And now you can relate it with the previous discussion, what I have said, that do not write too much, do not become too optimistic in terms of writing data analysis section in a research proposal. Now you can understand why. Because you don't know. You don't know that what will be the range of my data, what will be the standard deviation of my data, what will be the mean median mode of my data. You don't know. Therefore, it's better to be bit reserved in terms of writing your data analysis section, especially in research proposal when you are proposing it to someone. Be very specific, because you know this thing, that what kind of data you are going to have, but there may be chances that what you feel, what you think will be different from the reality. So move accordingly. Next is inferential statistics. It helps in making generalizations from sample to population. It is very clear. You can see here that inferential statistics are being used for making generalization. On the other hand, descriptive statistics is for understanding nature of data. Common techniques in inferential statistics: t-test, very famous, comparing means of two groups. Whenever you want to compare means of two group, and again I will suggest here that whenever you are going to take or select any kind of a test for your analysis, be very particular, be very specific to the demand of the research. For example, if you have three groups together in your research, you can't go for t-test. If you have three tests to compare the means of three tests, you have to move on towards ANOVA. You can see here comparing means of three or more groups. Chi-square test, a non-parametric test, association between categorical variables. Now here it comes the role of levels of measurement. You have to understand that your data belongs to which level of measurement. Accordingly, you have to move for selection of test also. Correlation and regression, relationship between variables. If your study says, if your research objective says that you want to see and analyze the relationship between any variable A and B, then automatically you have to move on towards inferential statistics, looking into the assumptions and requirement of the test. If it permits you, if it suits you, if it satisfies all assumption, move accordingly. Let us take one example here. Examining if attendance predicts academic performance. Very important how you do this. And most importantly, always remember, when you want to make generalizations from sample to population, it is recommended that you have to use inferential statistics. Without this, generalization will suffer and it will not be creditable that yes, it is very accurate and honest generalization. So you have to see into these aspects, that inferential statistics is very useful in terms of when you want to generalize from sample to population. Other aspect of quantitative data analysis, let us see educational applications. Analyzing student test score across different regions, studying impact of teaching methods on learning outcomes, survey based studies on teacher perception or student engagement. Good practice in data analysis ensures data accuracy and consistency. Choose statistical test based on research question and data type. Report effect size and confidence intervals. Use visualization of complement numeric results. Very interesting and very important these two discussions that you see here on the screen, that what are the good practices in data analysis, because ultimately you are going to make predictions, inferences out of your data analysis. So what kind of a data analysis practice will be considered good? You can see here, ensures data accuracy and consistency. Most important thing, your data should be accurately fed, coded, whatever you have recorded or whatever you have obtained, it should be accurately fed and with consistency. Choose a statistical test based on research question and data type. Very important. Whenever you are selecting a statistical test also, it is highly recommended and suggested that look into the demand of research. It's a suggestion here, you can make a note of this, that do not rush for any kind of a test. That is why I have said that do not go for defining the test in a research proposal, because you don't know what kind of data you are going to have. So be bit reserved, bit confined in terms of making and optimizing the data analysis section. Next is report effect size and confidence interval. Very important. What will be the effect size, what confidence level you are taking, whether it is 0.05, 0.01, what you are taking, you have to move accordingly, because selection of a statistical test in a quantitative data analysis is dependent on multiple factors. It not based on your choice. Always remember, test that which you will use in a quantitative data analysis is not going to be based on your choice. It is going to be based on multiple factors, that is research question, data type, requirement, how you want to do, what is the intent of your research. So all these things are affecting the process of selecting a test and adding into good data analysis. Use visualization to complement numeric results. That is more important. If you have some certain kind of results, try to make pictorial representation. SPSS, MS Excel, VVivo and R also, they all are competent software in terms of presenting your findings with the help of advanced pictures and diagrams. So you can utilize it to make it more effective. Software used for quantitative data analysis, you can see here on the screen. SPSS, easy interface, widely used in social sciences. MS Excel, basic analysis and graphic tools. R and Python, advanced analysis and customization. All these three softwares you can see, and you can utilize it as per the requirement. What is your requirement, you can go according to that, and it is suggested that whenever you do data analysis, I am just recapping it, that please align it with your data coding and feeding. Otherwise this process which is going to be easy with the help of this softwares will become more difficult, and it will become more difficult, you will lose the way, because manually feeding data into this software, whether SPSS or Python or VB1, it is a bit difficult thing. You can assume by yourself that if you have to fill the data of 500 peoples. If you have to fill the data of 500 peoples in SPSS one by one, you can imagine how much time will it take. But once you are filling your data properly in MS Excel by proper coding, defining and feeding with a systematical approach, you can fetch it in a one click to SPSS. You can fetch it in a one click to SPSS, and then you can move on and do the analysis as per your requirement. So take care of these things. Limitations of quantitative analysis. First, may overlook contextual and subjective aspects. This is very serious issue related to quantitative analysis, because when you do qualitative analysis, your analysis is always revolving around the context of the research. But when you are dealing with quantitative analysis, there is a threat of losing, missing and being misguided from the context, because actually you have a number and all. You have a number, you have a numeric value representing all the aspects of your research what you have designed. So do not overlook the context and subjective aspects while you do quantitative analysis. Next is requires appropriate sampling and instrument validity. This is very significant, because let us go in a reverse process. When we were discussing about our research tool and instrument, we have discussed that a research tool should be developed by the researcher, can be adopted or adapted. But when the research tool is developed by the researcher, then it is highly recommended that a researcher should standardize the test, means should establish the reliability, should establish the validity and objectivity of the tool, so that whatever data you collect with that tool, that data will be reliable and valid, because your instrument is valid, your instrument is reliable, so it yields the data which is very authentic, relevant to the research. Otherwise, there may be chance that if your tool is not appropriate, definitely you are going to have wrong data, and when the data is wrong, ultimately analysis will be vague and wrong. Next is cannot capture depth of participant experience. This you can consider as one of the limitation of quantitative analysis and quantitative research. It is not that quantitative analysis are not useful and that it's not go to take the participant experiences, but when you want to go more deeper to the subject aspect, when you want to have more interactive data means you are spending more time with the subject, talking to the subject on several kind of dimensions. Because you see, when you are giving a questionnaire to the subject is filling with a pen hardly 10, 15, 20 minutes depending upon the number of questions you have. But when you do interview with the subject, you interact more with the subject, you talk more with the subject, and as a researcher you are also a human being. You can identify gesture, facial expression, happiness, sadness that add on to your researches, and you have the value of it. But quantitative research are not like that. They look into the numbers, what they have filled, you are analyzing and coming to the interpretations. So it cannot capture depth of participant experience. Concluding discussion from this lecture, major takeaways: quantitative data analysis enables objective interpretation through numerical evidences, ensuring clarity and precision in research finding. Second is selection of appropriate statistical tool, descriptive or inferential, depends on research question, data type and hypothesis formulation. Third is software tools like SPSS, Excel, R or Python streamline the analysis process and enhance the reliability of the result. So in a nutshell, I can conclude that whenever you are going for a quantitative data analysis, it is highly recommended that you have to take care of these important things, because there are many small factors that becomes major when you avoid it while doing data analysis, especially for quantitative data. So look into this all aspects and try to articulate a well components of data analysis in your research proposal. So this is all from this lecture. Thank you.